In this video, we will go over Excel Project 9 in our Statistics OER course for hypothesis test on 2 samples. Make sure you open the PDF of the description and download the Excel file, which I have already downloaded over here for me. And I'm gonna go here and look at the description. It is a hypothesis test on dependent samples. It is from the example of our Intro Statistics by OpenStax textbook, and it's a study for investigating the effectiveness of hypnotism in reducing pain for adults 30 years old or older. The results of randomly selected subjects are shown in the table below. A lower score indicates less pain. The before value is matched to an after value, and the differences are calculated. The differences have a normal distribution. Are the sensory measurements on average lower than hypnotism? Lower after hypnotism. And we want to conduct a hypothesis test at 5% significance level. Now notice that your Excel file already has these values in it. And we have to think what the appropriate alternative hypothesis will be. So it is left to us to make the decision. And the alternative hypothesis is for us to check if the sensory measurements on average are lower after hypnotism. Now, when we are conducting a hypothesis test on 2 dependent samples, we have a difference of population 1 minus population 2, or group 1 minus group 2. In this case, it is before minus after. And we want to check if hypnotism helped by reducing the pain of adults. Notice here that it is indicated in boldface for us. So reducing the pain means that we want the before pain to be higher than the after pain, or we hope that this is true if we want to check whether hypnotism was effective. And therefore we are looking for a before minus after quantity to be significantly positive compared to negative. So we hope that in most cases we will have a positive difference of higher pain levels before minus lower pain levels after. So just keep that in mind. So we want to compare 2 means in artofstat, and we want to enter the data of our own. Actually, I'm not reading carefully here. It says to select the tab for 2 dependent samples. So actually, I don't want to be here. I want to be in the tab that says 2 dependent samples, and I want to provide my own data. The response variable is the pain level. They are asking me, let me make this smaller so we can read here. They are asking me to select group 1 to be before and group 2 to be after. So it is very important that you clearly state what the 2 groups are before you start your hypothesis test. If I had chosen group 1 to be after and group 2 to be before, then my after minus before value, I would expect it to be negative and not positive, because I would expect the pain level after to be smaller than the pain level before. So after that, it tells us to enter the group 1 data and group 2 data by copying the columns from the Excel file. And we want to do that very carefully. Make sure you copy one at a time. So this is the before data, which is group 1. And I'm going to put it under group 1 data. And the after data, which is group 2. And I'm going to put it after in the box for group 2 data. And then it says select the type of plot to be a box plot, and it is already selected for me by default. Then it says select the type of inference to be a significance test, and I will change the confidence interval to a significance test. Select the appropriate alternative hypothesis for the particular test we are conducting. What are we investigating? What does this mean for the difference before minus after? So we are investigating the effectiveness of hypnotism in reducing pain for adults. So we want the before minus after to be positive, and therefore we have a one-sided test that is greater than. And then it says here select show degrees of freedom, so I'm gonna select that. Then it says select show the null value for differences, and I just in the new version of the app it's just called null value. We want the null value in our null hypothesis to be 0, assuming that hypnotism did not have any change in pain levels, and our alternative hypothesis is that it did, and it reduced them. And then it says select the decision, reject or not reject, select the appropriate significance level using the slider. And if I do here test decision, again, this is the newest version of this app. There is no slider here. I just enter the significance level to be a 5. And you want to take a screenshot of your artofstats input and output in your Excel file. Make sure all the parts of the window are included, including this left pane, and resize your image to fit within the indicated area. And of course, you know by now, I hope, that, let me move this up here, artofstat has created for us a screen, and we want you to take a screenshot of this and insert it in your Excel file in the appropriate location, which begins in cell H19. One note here is that artofstat actually gives me an error, and it doesn't give me the test decision, whether I should reject or not reject. So this message is okay to be there. Make sure you have copied the tags here, the tab, the title of the app you're using, the tab you are in, and all of these pieces. And the rest of the project is to recreate the box plots and the histogram of differences in Excel. So let me move this here. Let me bring up my Excel. I will want to recreate the box plots, highlight the titles and values for before and after, and insert the box plot. So titles before and after, and the data values. Under insert, go under recommended charts, all charts, and insert the box and whisker plot. Position the box and whisker plot in the correct location. Let me enlarge this a little bit so we can see where we are going. Make it fit in that box. It says add a vertical axis title and adjust that together with the chart title to be identical to the artofstat box plots titles. So look again here in artofstat, make sure it says box plot, make sure there is a before and an after, make sure there is a pain level on the y-axis. Remember, Excel does it vertically, these are horizontal. Add a legend and change the colors of each box plot, fill and border to agree with the color in artofstat. So remember how to do that from project number 2, where we played with the box plot and make them look green and yellow or something similar to that. So I spent some time to add an axis title, make sure it is a good title here. You need a chart title, make sure it's a good chart title here. I changed the colors. One thing that I notice Excel is doing is actually keeping here a 1 for an axis title. On the horizontal axis, I want this deleted. So just delete that so that it's not there. And then here are is my box plot. The next part is I want to do a histogram. So I highlight the column differences, title and values, and insert a histogram. We haven't done the differences yet, so let's try to find the differences. We have to do them ourselves. So there is a column here in our Excel file that has the differences, and the differences have to be before and after. So let me zoom in a little bit so we can see. So in the difference in row 5, I want to say this is equal the before minus the after in row 5, and then just copy down, and it will calculate the differences for us. So to enter the histogram in artofstat is of the differences, right? Distribution of differences. And you see how the title says that these are the differences. So we want to highlight the column differences, title and values, and insert the histogram. It defaults to 2 intervals. Change the number of bins to 11 in order to agree with the histogram in Excel. In artofstat, it meant to say here. Add axis titles and adjust those together with a chart title to be identical to the ones in artofstat. Change the fill and border of the rectangles to resemble the ones in artofstat. So let's try to follow these instructions. I want to highlight the title differences and the column differences, and I want to insert, and here I'm going to go under the histogram and I'm going to insert the histogram. It does, the project did tell us that the Excel will default into 2 bins, and we will have to fix that. So let's put it where it's supposed to go. Let's scale it so that it fits here. And let's try to make the bins 11 bins. To refresh your memory to do that, we need to click on the label for the axis where the 2 bins exist, and then either plus or right click on it. And let me try again. I need to be on the bin. There we go. And then right click here and format this axis. And it's going to tell me I can click on the number of bins. I don't want it to be 2. I want it to be 11. And when I do that, let's press enter, I will see the number of bins. They are written with a lot of accuracy, so unfortunately these values are sideways and I cannot see them very well, but that's how Excel is going to look like. Excel is not going to round so that we can have a better presentation of data here, like this that says 4, 6, 8, 10, etc. So it's fine. It's just considering this as a continuous variable. Remember to add a vertical axis. Remember to... So I need axis titles. I don't want them, or maybe I do want them both. So let's try to add them both. So I'm going to click on this and it's going to add both titles. Make sure that you tell me what this is, the vertical axis. So change this title. These are frequencies per the graph that I see here. Make sure you tell me what is on the horizontal axis, so change this axis title, these are differences, and also make sure you give me a chart title, which is basically a distribution of differences per artofstat, since we are trying to imitate that. Again, remember to change the colors here. Let's see how we can do it. So if I right click on this, I can change the fill And then I can change the outline to be black and maybe make it a little less thick. Let's make it 3/4 of a point so that it looks a little better. There we go. So I already recreated the backsplots and the histogram from the data that I found. The next part is to embed formulas in Excel that complete the hypothesis test as shown in artofstat. Use variable locations in your formulas. So in B5 to B12, the before data is already provided. In C5 to C12, the after data is already provided. And in D5 and D12, you have created the differences of before minus after using locations. F5 and F8, enter the alpha as a decimal in F5 and enter the null value for the mean difference in F8. So the significance level is 0.05 and the null value for the difference is 0, which indicates the theoretical assumption that there was no effect of hypnotism. And then in B17 to 19, C17 to 19, D17 to 19, we want to calculate the sample sizes using the count function, the mean using the average function, and the standard deviation using the appropriate standard deviation function to calculate sample standard deviations. So here in sample size, I'm going to say this is count, and I'm counting the before group, which is here. Close the parentheses. There is 8 of them. The after will be count, and I will count the after group. And the differences, again, for the sample size, I will use count, and I will count the differences. The mean equals the average, and I will highlight the before group, and then below that I will do the other average, and I will highlight the after group, and below that I will do the other average, and I will highlight the differences. And for the standard deviation, stdev, I need to calculate the sample standard deviation, so I'm gonna select the function .s, and I'm gonna highlight the before group. Let me see what I did wrong. I did an underscore here, and then here I'm gonna do again the stdev.s, and I'm gonna highlight the after group. All right, I'm typing, I keep typing an underscore instead of the parentheses. And for the last one, for the differences, stdev.s. And again, I'm going to highlight the differences and close my parentheses. And now I have found the standard deviations. So going back to artofstat, I need the null value to be 0, the observed difference, the standard error, the test statistic, and the degrees of freedom. So for the null value, if you remember, was entered up here by the user in F8. The observed difference equals to the mean that we found of the differences. So it's this location, 3.125. Matching with what artofstat was giving us. Artofstat rounded a little further. The standard error is equal to the standard deviation of the differences divided by the square root of n of the differences. And in paired samples, all the n's must equal to each other, otherwise it's not paired. So the standard error here will equal the standard deviation of the differences divided by the square root of the n of the differences. So make sure you have selected the correct cells for that. And the test statistic T can be found using the formula, a sample mean of the differences that I found minus the mean of the differences from the hypothesis, the null hypothesis, divided by the standard deviation of the differences, which I just calculated in the previous cell. So the test statistic here will equal, you can do parentheses, observed difference minus the null value, which would be the ideal situation, so that if someone enters a null value that is non-zero, you take that into consideration, divided that by the standard error you also just calculated. So this is the test statistic, 3.0359, that agrees again with artofstat for 3.036, and the degrees of freedom equal the number of differences minus 1. So this will equal the count that I found here, the sample size minus 1. That will be a 7. So for the hypothesis test, we want to type the population parameter description as listed in artofstat. And artofstat here listed that the population parameter was the mean difference mu sub d. So that's what we will enter here. So I'm going to say here in the population parameter, mean difference, and remember to insert a symbol. And from the symbols to pick the Greek letter mu. Insert that and close, and I will just do a D here, and that will be close enough. So mu D. Let me make sure that they are all the same size. This looks a little too much. Okay. The null hypothesis was that the mu D is equal to 0. I copied it from the previous one. That was the null hypothesis. The alternative hypothesis was that the mu D was greater than 0. And again, remember that we said that we want the differences to be before minus after, larger minus smaller pain level. If you don't remember that, also just copy it from artofstat right here. You may want to also make sure that it looks like artofstat so that you can say H sub 0, semicolon, or colon says MD equals to 0, and H alternative. So we could potentially also enhance this a little bit to say that this is the null hypothesis and this is the alternative hypothesis. The test statistic, we just found it earlier over here. And for the p-value, we want to use the correct t-distribution. Do you want to do a left tail, a right tail, a two-tail to find the p-value of the test statistics? The t-distribution needs the x value, which is your test statistics, and the degrees of freedom that you actually calculated earlier. So which way is this hypothesis test calculating the p-value? If the alternative hypothesis is to the right, I need to do a right tail t-test. So the p-value here will be t-distribution, not two-tail, but right tail. And the x will be my test statistic, comma, and the degrees of freedom were calculated in E23. And this is my p-value. So again, let me double check that I have done everything according to what artofstat said. Artofstat said that the p-value is equal to 0.0095, and I found a p-value of 0.009477988, which would correctly round 2.95. So I have a p-value that is very small. So p-value is less than alpha, indicating a very unusual outcome coming from the theoretical distribution that assumes that the mean of the differences in pain levels is equal to 0. Therefore, my decision will be to reject the null hypothesis, and my conclusion will be that at the 5% significance level, the sample data provides sufficient evidence to support the alternative hypothesis. And the alternative hypothesis is that hypnotism reduces pain level for adults 30 years old or older.